Okay, this is Wake Up! Getting going in the morning was probably hard for folks on the Overland Trail, which was a unit from another class, just as it may be for you today. So coffee was highly valued commodity. The Kasniau family starts their journey with a supply of 30 pounds of coffee. Starts with 30 pounds. When they arrive at Stutter's Fort in California, 188 days later, they only have 3 pounds left. Draw a graph showing the amount of coffee remaining as a function of time, as a function of the time elapsed since the start of the journey. For simplicity, assume the Kasniaus consume coffee at a constant rate. This just made this problem so easy. Whenever y'all see a constant rate, you should say, oh my gosh, math is so easy. A constant rate is easy to predict. It's and easy to model. And so what we're going to actually end up modeling is we know that if they, start, which would be day 0, right? Day 0, they'll start with how many pounds? 30 pounds. And then they end on day 188 with 3 pounds. And so we're going to flip this page over and show a graph that starts at 30 and ends with 3 constantly. Oh, we love constant stuff. Okay, starts with 30, 188 days, has 3. So let's see, our y-axis is going to be, this is going to be pounds of coffee. And then our x-axis is going to be days. Oh, let's see. Let me think a little bit how I want to set this up. I know we're going to start with 30 and we're going to end with 3. So we could actually break that up by like if we had it 10 high, we could decrease 3 every time. And that would be from 3 times 10 is 30. But just to make the graph a little bit bigger, let's make our 30 up here. And then we'll decrease 3 every time. So this will be 27. This will be 24. Then 2 more is going to be 21. Then we'll get down to 18, 15. Oh, am I already doing this wrong? I feel like I'm not going to have enough room. Maybe my logic's off. Let's see what happens. 12. What's after 12? 9. Oof, 6. How did I get off? 3. Well, man, this is just going to be sloppy now. That's okay. Sometimes artwork just gets sloppy. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I guess disregard what I said at the beginning. And then this will be our days down here. Luckily, we're going to end at 3, and that'll be towards the end. So I'm going to actually mark the days right here. So once again, I apologize for this. Okay, so anyways, so if we count our days, we know we're going to want to end on 188, and let's think of what numbers go into 188 just to make counting clear. 188 divided by, I don't know, 12? 188 divided by 16? Not quite. 188 divided by 17? 188 divided by 4. It's 47, okay. 188, oh, what about divided by 8? Oh. You know, maybe there's not going to be a super clean thing, but watch this great trick. I feel like I'm already spending too much time on this, and since I'm on the clock, feel the pressure. So I'm going to take whatever number this is right here, and this point is going to be day 188. And here's what we know. We know that we are going to start on day 0 with 30 pounds of coffee. So I'm going to put my dot there. And we know 188 days later, we're going to have 3 pounds of coffee. So if I follow this out and try and stick with the scale, so we're going to go 1, 2 spaces down, that's going to be 3 pounds of coffee. Now I can use my straight edge to connect the dots, and the only reason I can connect these dots is because the rate of change is constant, which in math we love because it means we don't have to think about what happens in between. We can just change it. Okay, so there we go. Did it. 2, find the average amount of coffee consumed per day. Well, I think I just want to use these 2 points. So let's make this one our x1, y1, x1, y1, and we'll make this one be our x2, y2. There's commas there. So then our rate of change equation is going to be y2 minus y1 over x2 minus x1. And that's going to be, let's see, y2 is going to be 3 pounds of coffee, and y1 is going to be 30 pounds of coffee. x2 is 188 days minus x1, which is 0 days. So 3 minus 30 is negative 27, and 188 minus 0 is 188. And you can see right here already that we're going to have a negative fraction. And that is good, right? Because that means we're decreasing. That means the amount of coffee we have is going down and not going up. We're not banking coffee, we're spending coffee. And so that makes great sense. So let's see what 27, let's see, I can even put a negative. Negative 27 divided by 188 is going to be negative 0. Let's just do 14, and that's going to be pounds of coffee per day. So 0.14 pounds of coffee per day is how much what's the family name? The Krasnow family loses. Okay, so develop an equation, find and imagine, blah, blah, blah. Okay, so that was negative 0.14, which is pounds per day. Okay, develop an equation. Well, wouldn't the equation be our rate of change? So let's say our coffee as a function of days is going to be however much we start off with, which is this 30. So we start off with 30 pounds, and then we lose 0.14 pounds per day, D. And that's times D, by the way. Okay, so that's our function. So this is answer, develop an equation for the function of your graph. Find the average amount of coffee consumed per day. We did that. And then find the slope of your graph, which is actually the exact same thing, right? So we know that the slope of the graph is the same as the amount of coffee consumed per day. I guess maybe with the difference being you consume 0.14 pounds of coffee. You don't consume negative 0.14 because in the word consume, there's that negative connotation. But here, the slope specifically is going to be negative 0.14. So next, we're going to suppose that at the beginning of their 188-day journey, the Krasnows are 1,600 miles from Stutter's Fort. Okay, that looks important, 1,600 miles. How many miles per day do they have to travel? Assume they travel the same distance each day. Oh, okay, well then over 188 days, they have to go 1,600 miles. And so we need to know how many miles per day, which already tells you the math we need to do, right? Oops, sorry, it's out of focus. Well, isn't that just going to be 1,600 miles in 188 days? So we could do is 1,600 miles in 188 days, right? Miles per day. Per is math language, it's division. So let's figure out 1,600. Sorry, I gotta pay attention to the focus of the camera. 1,600 divided by 188 is gonna be 8.51 miles per day. Okay. Got it. Then, of course, the Kasniaws travel their distance from Stutters Fort. Wait. Oh, as they travel, their distance from Stutters Fort increases. Write a formula expressing the distance remaining as a function of the number of days they have been traveling. Okay, so let's think about this. So it's trying to say, especially the distance remaining. So thinking about the start versus halfway through, at what point do you have more distance remaining? So at the start, you would have all of the distance, right? So that's 1,600 miles is your distance remaining. And at the end, you'd have 0 miles as your distance remaining, which that tells me that the distance remaining is what we start with. So if we were to draw this on a graph, oh, it actually tells us to make a graph of the function from part B. Can we do it on here? No, I don't want to make it too sloppy. We can actually do it, a pretty informal graph, where if we start, we know we're going to start at 1,600 miles, and this will be in miles, and this will be days, and this will actually be miles remaining. And we know we'll end with 0 miles remaining. We're going to start on day 0, and we're going to end on day 188. And so we know on day 188, we're going to make it to wherever we're traveling, Stutters Fort, which is going to be, if we're at Stutters Fort, then there's going to be 0 miles remaining. And then, since we're traveling, wait, are we on average? So we're writing from an expression the distance remaining is a function of the number of days they've been traveling. And we're assuming they travel the same distance each day, which is a constant change, which means we can take our start distance remaining and our end distance remaining and connect it with a straight line. So there's our graph. And then find the slope of your graph. Well, what do you think the slope is going to be? We could do our classic y2 minus y1 over x2 minus x1. That's going to be, let's see, if we call this one x1, y1, and this point x2, y2, then we can say, well, that's going to be, our y2 is 0, our y1 is 1,600. Yep, 0 minus 1,600. Our x2 is 188, our x1 is 0. So 188 minus 0. And then, if we simplify that, we've got negative 1,600 divided by 188. We've actually already done this math right here, with the exception of this one is negative. So we're going to write out the same number here, but make sure it's negative. And that is our slope. Check. Okay. Thanks for watching.